Section 5.2 is one technique of integration. We have 5 techniques altogether. We're going to learn only one. And that makes it really simple because that's the only rule you know. Integration by the substitution and the general power rule. That is, if I look at an integral and I'm integrating x to the n dx, we know that's going to be x to the n plus 1 divided by n plus 1 plus c, provided n does not equal negative 1. So that's the rule up till now. I see a power function. I add 1 to the power, divide by the new power, add the c, and that's pretty much it. Now what we're going to do, we're going to look at an integral that I'm doing the chain rule. If I look at the integral of f of g of x times g prime of x, which is the chain rule. If I let u equal, and it's going to be the same literally as the chain. If I let u equal the inside of a radical, the denominator of a fraction, the exponent of an exponential, the argument of a log, the angle of a trig. So if I let u equal g of x, then if I take a derivative, that would be g prime of x, and if you cross multiply, you get du to equal g prime of x dx. What that does, that will transform the integral and it will become f, a function of u, times du. The blue part is right there, and the yellow part is right there. And this we should be able to integrate because that's going to be a power function in this section. So, not to worry, we have plenty of examples to practice with. So I'd like to start with number 2. The key is figuring out what u should equal, and keep in mind how this works. You want u to be the inside of a power function, the denominator of a fraction, the inside of a radical, the argument of a log, whatever you're taking the log of, the power of an exponential function, and so on and so forth. So if I glance at this, I really want this to be my u. U would be the inside of a power function. That's a power function. And why is that? You're trying to get a power out of this, and you know exactly how to integrate that. So if I let u equal 3 minus 4x squared, and I'll take a derivative, that would be, what's the derivative of that? That is negative 8x, and if you cross multiply, do you notice this is right there? Doesn't that make this the integral of u cubed? If you really pay attention to what we did the substitution, we let u equal 3 minus 4x squared, the inside of a power function. And do you see that du is right there? And what's the point out of this? Well, the point is simple. I could add 1 to the power. Here they're saying identify u and du dx. They're not saying to work it out. But we could work it out, or we could stop here. It doesn't matter. Let's work it out. How do you integrate a power function? Right there, we add 1 to the power. We divide by that. Don't forget the plus c. Now there's only one minor amendment you have to make and you're fine. If you look at the original problem started with x. So at the end, you want to bring u back in. And what was u? U was 3 minus 4x squared to the 4th. If you take a derivative of this, you will get this. And I'm going to show you that. Of course, we're not going to do that in every problem, but I just want to show you really quick that this does work. So if I take this answer here And if I take a derivative of that, if I take the derivative of 3 minus 4x squared to the 4th over 4 plus c, what should I get? I should get this, the whole thing. So that would be the 1/4 you leave alone, bring the power down, subtract 1 from the power, times the derivative of the inside by the chain rule. What's the derivative of this? Isn't that negative 8x? And wouldn't these 4's cancel out? And do you notice that this right here is literally this right here? So again, you don't have to do that, but you could always check your answer. If I look at number 6, what should I let u equal? I am going to let u equal the inside of a power function. That's the inside of a power function. So if I let that be 1 plus 2x, that's my u. A derivative of that will be 2 du dx will be 2. That's the derivative of this. And if you cross multiply, you will get 2 dx. So from now on, I'll start, since you're going to cross multiply every time, I'll just say du equal 2 dx. Or you could write that step if you wish. What happens, that will transform this problem. My u is right there, but it's being squared. And do we notice that du is right there? And that's what? So doesn't that make this the integral of u to the negative 2 du? Can't you add 1 to the power divide by that? Can't you say, well, that is add 1 to the power divide by that? And then don't forget that you're going to write this as negative 1 over u. And do remember that you started the problem with x. You have to really put u back in. And u was 1 plus 2x. So on numbers 1 through 8, they're just saying identify. We solve them, that's okay. Extra practice, that doesn't hurt. Here, from here on, they say, okay, find the indefinite integral. Indefinite means that there's nothing on these numbers. There are no numbers on the limits of the integral. So that's general. Definite, that's coming up. So when I glance at this, now I do want to warn you, sometimes you're off by a constant. What should I let u equal? The inside of a power function. Here we want to solve. I should let u equal x squared minus 1. And if I take a derivative, that will be 2x. And instead of writing du dx and cross multiply, I'm just going to write it this way. And I'll check. This is my u cubed. Again, that's my substitution. And do you notice that 2x dx is actually du? Sometimes that number is not there, the 2. So we have to adjust. So wouldn't this be add 1 to the power, divide by that plus c, and don't forget the last step. You need to go back to what you started with. So what was u again? U was x squared minus 1. And that's how we do these problems. So that's one of 5 techniques to integrate. We're just going to learn this technique, nothing else. And if I look at number 14, I'll notice that, well, I need the u. Let u equal, is it this? Well, think about it. If I take a derivative of this, would I get that? Take a derivative of x to the 4th plus 3x squared. Isn't that? Yep, that works. And if you get it wrong, automatically it wouldn't, once you do u and du, you'll notice things didn't work out. So if I let u equal x to the 4th plus 3x squared, this is what I did so far. So far, I took this first parenthesis. I took this first parentheses and I replaced it by u. There's no power there. And if I take a derivative of this, isn't that 4x cubed plus 6x, and it should be du dx, but I'm going to cross multiply. And do you notice that all of this right here is all of this right here? That's simply du. And doesn't that make the problem u squared over 2? Add 1 to the power, divide by that, plus c. And we don't forget that we need to substitute u back in. What was u? U initially was x to the 4th plus 3x squared. And this is undoing the chain rule, one type of it. But that's all what we're going to focus on. How about here? You're going to let u equal the inside of a radical, the inside of a power, the denominator of a fraction, 1 minus 2x squared. If I take a derivative of this, isn't that negative 4 dx? So in this case, I see it clearly. That is the integral. Can't I write this as a u du? A radical, isn't that a 1/3 power? Don't you add 1 to the power and divide by that? So add 1 to the power. 1/3 plus 1 is 4/3. And when you divide by a fraction, you multiply by the reciprocal. And do not forget, this is the cube root of u to the 4th plus c. Don't forget to bring u back into the equation. What was u? U was 1 minus 2x squared. And if you have time, take a derivative of this, you will get that. That's always the case. Again, sometimes you're off by a constant, and that's coming up. How about this problem? Well, if I let u equal x minus 3, the inside of this power function, the derivative of this is simply 1 dx. So I notice, hey, it matches. This is the integral of u to the 5/2, and dx is really du. There it is. Add 1 to the power. 5/2 plus 1 is 7/2. Divide by that, that's 2 over 7 plus c. So this is 2 over 7 times the square root, or since the power was a fraction, you could leave it as a fractional power. We're not going to disagree on that. Whether you write it this way or this way, it makes no difference. And don't forget to put u back in, and u was x minus 3. And there it is. Now, sometimes you're off by a constant, and that's starting with number 20 and on. Most of the time you're off by a constant. It doesn't match exactly, but it's okay. Off by a number we can fix. So here, I notice, well, there's a power function. I'm going to let u equal 7 minus 6x squared. If I take a derivative, so up till now, this is what I have. Up till now, I have a u and raised to the 5th power. And if I take a derivative, that is negative 12x dx. I glance up there and I say, wait a minute, we have a problem. There is an x dx. I don't see a negative 12. I just want this by itself. Well, using algebra, what would x dx equal? What do you think? Can't I divide both sides by a negative 12? And I'll say, you know that blue part you see up there? I'm going to replace it by what it equals. And what is that? That is du with a negative 12. And that's an easy fix. Why is that? Because we know that we could factor a constant out. And that's really what the problem looked like. So every now and then, you glance, you notice the variable part is matching, but you're off by a constant. That's an easy fix. You could divide both sides because that's a constant, and you could just drag the constant up front. Don't you add now 1 to the power and you divide by that? And what do you notice happens? You end up multiplying those. That's negative 1 over 72. And don't forget what u was. U was 7 minus 6x squared. And that's as complex as things get for us. So 3 more to practice. We want to make sure we get this down. And then a couple of applications. What we're going to let u equal? We're going to let u equal the inside of a power function, which is this. So up till now what I have is the integral of, I have a u squared. And I'll take a derivative, that's always the case. If you bring the power down, that's 9x squared dx. And I'm glancing to see if I'm off by a constant. And again, I know it's unpleasant, but guess what? That's always the case. I am off by a constant. Well, if I want to get x squared dx by itself, can't you divide both? Isn't that an equation right there? Can't you divide by 9 both sides? And I could automatically say, you know what, I'm going to put du over 9. And since I know 1 over 9 is a constant, I could drag that up front from the very beginning. And what do you notice happens here? This is 1/9. Don't you move this up? That's u to the negative 2 du. Add 1 to the power and divide by that. That's 1 over 9. Add 1 to the power. That is u to the negative 1 over negative 1 plus c. And wouldn't that be negative 1 over 9? Don't you move this down? And what was u? Again, make sure that you input u back, and there's u. That is 3x cubed plus 8. 30. Same deal. I'm going to pick a u. I'm going to let u equal, in this case, the inside of a radical. Oops. The inside of a radical. That is x to the 4th plus 2. du will be 4x cubed dx. I'm glancing at the problem and thinking, wait a minute, this is way off. I see an x cubed, but there's a 9. I don't even have a 9. Well, watch this trick. Since this is a constant, I could drag that up front. I could say that's the integral of x cubed, or even better, write it as the square root of x to the 4th plus 2 x cubed dx. Now, do we agree that this is simply u? Raised to the 1/2 power. There's a 9 up front. And we have another issue. X cubed dx is right there. So wouldn't x cubed dx equal du? And you would divide both sides by that 4. So can't I replace the x cubed dx with a du? And since the 4 is a constant, I could drag it up front. Basically, you're multiplying. Wouldn't that be 9 over 4? Add 1 to the power. If you divide by 3/2, that's like multiplying by 2/3. And wouldn't this reduce and this reduce? Wouldn't that be 3/2? The square root of u cubed? And do remember what u was? U was x to the 4th plus 2. And if I look at the last example before we get to the applications, we have this function. Well, we let u equal the inside of the power function. So a power function is any quantity raised to a number. That is 5x minus 3. So far I have the integral of u to the 2/3. And if I take a derivative, that is 5 dx. And again, the same problem. I notice there's only a dx. I need to get rid of that 5. Don't you divide both sides by 5? Because that's an equation. So when I want to take the x out, I want to replace it. I'm going to replace it with a du, and I'm going to take the 1/5 up front, because that's a constant. And wouldn't this be 1/5? Add 1 to the power. Isn't that u? 2/3 plus 1 is 5/3. And divide by a fraction, you multiply by the reciprocal. Wouldn't that be 3 over 25 times I just need a bit more space. Times. So the rule of thumb is times what? U. U is 5x minus 3. The rule of thumb is if you start the problem with a radical, you want to write the answer as a radical. If you start the problem with a power function, which is a radical, you write the answer in a power function. To me, I don't mind either way. No matter how you write this, I'll accept it. And here's our first application. The marginal cost of a product is modeled by this equation, where x is the number of units, right? And c is the cost. When x equals 13, c equals 100. Find the cost function. Well, if I take dc dx to be 12 divided by the cube root of 12x plus 1, if I cross multiply, can't I say dc equal I'll get it right, just give me a minute. There we go. So in part A, if I want the cost, you integrate. What's the derivative of dc? That's the cost. And I'm trying to integrate. Isn't 12 a constant? Actually, I rushed. Now, the cost function is simply the integral of this. I just need to integrate. Well, let's see how this works. C is going to equal, and do you see this is a u? And if I take a derivative, isn't that 12 dx? So in this case, it matches perfectly. This is going to be the integral. And if I take a u in there, that will make this the cube root of u. And 12 dx will be du. The cost will be the integral of u to the negative 1/3, right? Add 1 to the power and divide by that. Negative 1/3 plus 1 is 2/3. Divide by that, that's 3/2 plus c. Actually, let's use k if you remember in applications, because c is reserved for the cost function. And if I really glance at this, say, wait a minute, I get this. This is 2/3 the square root of 12x plus 3, the cube root. I want to make that bigger. The cost function is 3/2 the cube root of 12x plus 3 squared plus k. Now what? In applications, k is a problem. They told me when x equals 13, the cost is 100. The cost is 100 when x equals 13. 12 times 13 plus 3 squared plus k. So if I get my calculator out, if I take 12 times 13 plus 3, 159. If I take the cube root of that, so I raise that to the 1, or if I take raised to the 1/3. Okay, I'm gonna redo that. It seems I messed up a bit. So if I take 12 times 13 plus 3, and if I take that and square it, right, I raise it to that, so if I square that, and if I take the cube root of that, so I raise it to the 1/3 power, multiply that by 3/2 times 3/2, I'll get 44.0 0259, right? And remember, these are dollars. 02. So K would be 100 minus that. 55.97. 55.97. Oh, okay, I see. I made a mistake. I'm sorry. There's a 1 right there. I put a 3 for some reason. You know what? Let's make that a 3. So I'm changing the problem slightly. Then everything matches. Assume that was a 3. My mistake. So, still no problem. What do we get? 55.97. 55.97. So, my equation, the cost function, is 3 over 2 cube root of 12x. It should be plus 1, but we changed the problem. That's okay. We can make it 3 plus 55.97. Got it. All of that work to get the equation, but that's the most important. How about in part B? In part B, they're asking, find the cost of producing 30 units. The cost of producing 30 units is 3/2 cube root of 12 times 30 plus 3 squared plus 55.97. Now, I did the previous problem a step at a time. Here, I'm going to do the whole thing one shot. So if I take 3/2, and if I take 12, now I have a key for a radical. I could use it. So I could hit that key. That's a cube root right there. Or I could raise it to the 1/3 power. Either way, I just want to make sure that you not do that in your calculator. And this is going to be 12 times 30 plus 3. Again, it should have been a 1 squared. Plus 55.97. I'm getting 132.30 cents. The cost of producing 30 units is $132.30. The cost of producing 30 units is $132.30. Okay, I want to do one more. This is messy as well, but it's okay. So here, oh, I forgot, let me get directions. So I want to look at this problem next, and this will be the last problem again. This says demand. So in exercise 55.6, find the demand. The demand is X, remember that? That satisfies the given initial condition. If I cross multiply, that's really what I'm looking at. And to find X, I would integrate. So X would be negative 400 is a constant times the integral. And let's see. Wouldn't you say that is negative? Wouldn't you say that is? Actually, I'm going to do it in 2 steps so you're not confused. Because I could have moved that up and made the a power negative 3 if I want right now. But just so that, you know, we're not rushing and you get a bit confused, let's get that out of the way. I'm gonna let that be my u, the usual. U equal 0.02p minus 1. And if I take a derivative of that, that is 0.02. It should be du dp, but I'm going to cross multiply, and there it is. So x is going to equal negative 400, the integral. If I put that in, wouldn't that be u to the 3rd? Do you notice dp is off by a constant? So can't I divide both sides by this and say dp is really du over 0.02? So there's the u, and since this is a constant, there it is. So now the problem just became an integral of, and what is negative 400 over 0.02? I get my calculator out, right? What is 400 divided by 0.02? That's really 20,000. Negative 20,000. And if I move this up, isn't that u to the negative 3 du? X equals negative 20,000. And add 1 to the power. Divide by that. So x equal negative 20,000 divided by 2 is 10,000. And x is 10,000 divided, and what was u again? Don't forget what that was. U was 0.02p minus 1 squared plus c. So I get the equation. The only thing missing is this c we don't like. That's why they give us when x equal 10,000, p would be 100. So once I solve for c, I plug it in there and I'm done. And I'm going to use my calculator for that. Wouldn't you say c equal the 10,000 minus this mess? So I could put that in my calculator one shot. I could say, well, let's see, 10,000 minus 10,000 divided by parentheses 0.02 times 100 minus 1. Oh, I didn't put parentheses. Wait, I thought I did put parentheses. Let's do it again. 10,000. That's 10,000. Minus 10,000 divided by parentheses. Right? 0.02 times 100 minus 1 squared. I'm getting a 0. What does that mean? That means x is actually 10,000 divided by 0.02p minus 1 squared. That is my answer. Since I got c to equal 0, all what I did was put that back in, and there it is. And there's your homework.